Welcome to our weather discussion. There's a lot that went on in this last week. Pete's got a few things some from our alumni, some that, of course, he makes every week. I just want to give you a broad overview of some of the things that are interesting to me this week. Number one, remote from here. London, England had 2 straight days of record high temperatures for their winter time, December, January, and February. They had 69 on, must have been Monday, and then they were 70.2, the first time they've ever been 70 in December, January, and February was on Tuesday. And there were pictures of all these Londoners in St. James Park, you know, in shorts and t-shirts, and there's daffodils blooming and all the rest. So pretty amazing for them. And then this part of what we see, just a little bit of the maybe some of the forcing that's driven that kind of extraordinary warmth and on the longitude of the dateline, the meridian, is this collection of intense cyclones in the Labrador Sea and then to the east of Greenland. Right now, there's going to see at the end of this movie coming up is storm number 1, storm number 2. So this one comes crashing south of the tip, and then there's this other one right here that goes crashing into the east coast. So on the eastern side of these massive disturbances, of course, there's pretty strong southerly flow, and that's been part of the story. Certainly not the whole story, but it's part of the story of the really exceptional warmth over the British Isles and even parts of Scandinavia. They haven't gotten that warm, but they're warmer than they should be. So it's been a pretty incredible end of the month of February in that part of the world. But now we're looking at can we start this again, Pete? Yeah, that's better. I don't like to. It takes a long time in the middle. So this is, and just stop it just so I can say a couple things. So this is starting a week ago today. And so we had, at the time, we were at the end of a period of time with a really strong flux of moisture poleward from the subtropics in the eastern Pacific into the central part of the United States. There was a really intense baroclinic zone lining up right over us. So we stayed chilly throughout that period. And then a deep trough, as you can see here, off the west coast of the United States. I should point out that we've just entered the month where Los Angeles has its coldest month of the year at 850 millibars, which is the month of March. So a feature like this is, though always interesting and noteworthy, is not really climatologically as anomalous as it would be 2 months ago or it would be 2 months from now. These things start to develop or affect this part of the world around this time of year. So it's and that of course leads to the situation in the Central Plains where the severe weather system season starts to mature, partly because you've got flow coming across with these upper troughs over the northern states of Mexico, and the Gulf of Mexico is proximate. You get all sorts of wild things going on as a consequence of that. So it's the beginning of a lot of seasons right now at the transition between February and March. But yeah,
I was just going to comment. You mentioned Los Angeles. This is March is their coldest month.
Yeah,
but they also just had their coldest. It is their coldest February ever. I should say coldest February ever. The first February in 136 years that they did not reach 70 degrees.
Yeah, that's amazing. That is amazing. Los Angeles did not see 70 degrees. Matt, how you doing? Good to see you. Los Angeles did not see 70 degrees all of this February. That's unbelievable. Unbelievable.
Did they shut down?
They're pretty nervous down there. You know, all the leaves are brown, as they say, and the sky is gray. So what we're going to see here, though, is the development of a really intense little cyclone that roared past us on Sunday into Monday morning. And we had really windy Sunday afternoon, cold advection for us. Not that much snow. We just didn't get, a fairly substantial hit by this. But just to our north and west, southern Minnesota, parts of northern Iowa, really get clobbered by this thing. So let's go ahead and watch that develop, Pete. So there were, I think, as I recall, there were a couple of different swaths of this. We had something develop in this southwesterly flow, and that was the first piece. And then this nice storm really gets wrapped up right there over the nose of Iowa near Des Moines, goes racing across the northern part of the lake. And over that 23rd and 24th of February, fairly impressive snow over southern Minnesota. And Jake Beitlich from, he's in Iowa, I forget
Minnesota.
He's in Minnesota now? He's at Chanhassen. Okay, yep. So he's in Minnesota now. He sent us some stuff, so can we bring that up, Pete?
Yep.
So here's our stuff from Jake from the Twin Cities Forecast Office. This is a military tank stopped in the snow. So there's about a foot of snow in many locations in the southern counties of Minnesota, not much north of Minneapolis, a little bit north of Minneapolis, mostly in the southern part of the state. And winds over 50 miles per hour. Wind chills went down into the -30 range with a foot of powdery crystalline snow. So the drifts were gigantic, and These people were stranded on the road, one of many groups of people stranded on the road. Here's a railroad, a train trying to come through the snow. So the snow is about as high as the top of the engine. Let's see, there's some other things in here. Here's a little bit of understatement, Minnesota understatement. This is a strong storm and we expect major travel impacts with road closures possible. They might have said, we expect very few roads to be open. That would have been a little more economical way to describe what we're going on.
Before the storm that one.
Yeah, so again, this was a pretty well forecasted event. So here's the number of traffic accidents. So they numbered in the dozens and sometimes close to 100 in many counties in the southern part of the state. So it was a pretty impressive event. And you could almost tell something had to be happening like that somewhere close to us, because I think it was the windiest day that we've had all winter long. We've really had an absence of well-developed cyclones come right by us until that one.
Right, and Weather Watch, when they issued, in the afternoon, Friday afternoon, they issued some of the blizzard warnings and watches for that area, but Weather Watch kind of anticipated that based on the track of the cyclone and the anticipated wind speeds.
Yeah.
It's a question of would we get those three criteria, the visibility, wind speeds, and one other criteria for the, maybe it's just visibility.
It's visibility, wind speed.
Right.
It doesn't have to be falling.
Right.
Yeah. So it was a pretty impressive event. So that's some of the highlights from the week. I've got some stuff to tell you about the highlights from the winter in a little bit, but maybe I'll stop that now. I'll just say that at the beginning. Michael and I happened to meet each other today as we were getting off separate buses right near campus. And of course he knew I was behind him. And so we ended up talking about, since it's going to get cold this coming couple of days, and we wondered what's the month that has the greatest extreme between its all-time high and its all-time low. So we had, uncharacteristically, we had an argument about it. And I thought it might be December, but Michael was right on. He said, no, you're not thinking about this right. You got to get the really high temperatures that we had 10 times over 80 in the month of March over the course of history. That's probably the month. Turns out he's right. The all-time minimum for March was set on March 1st, 1962, minus 29. So if that had been 1964, it would have been February 29th. The next coldest March day is minus 14. So that's a really big gap, 15 degrees. Okay. But the warmest ever is 83. So it's 112 degrees temperature difference between the all-time lowest and all-time highest. And that beats any other month, including January, which has the advantage of the minus 37, it's all-time low. That was 99. January comes in second, but it's 13 degrees off. However, if that minus 29 was not on the 1st of March that year, it would have been different. But it was, so you can't say that. No ifs, ands, or buts on that. March is the worst month in terms of extremes. And it has the best month. It has a great appellation, of course, in like a lion, out like a lamb. We're going to be in like a lion this time for sure. We don't know what we're going to be out like, but we're definitely in like a lion. We may get close to the second place, minus 14, on one of these nights. I would think it might be Monday night into Tuesday or a Sunday night into Monday. So one of those two, we might get as cold as minus 14. I don't know if that's going to happen or not, but I hope it does so we can kind of plow some new meteorological ground. So anyway, that's a little bit background for that. Let me just show you about the winter though. Yesterday was the last day of the meteorological winter, December, January, February. So here's the 850 millibar cold pool aerial extent that starts from December 1st, and I always carry it only to the 28th of February. And the blue line is the daily calendar average from the NSEP reanalysis data. That's 71 years. It's actually a 66-year average, but it was made in 2013. So from all of the data that was available. And then plus and minus 1 standard deviation. So a couple of interesting things happened this winter. Number one, we added 2 more days to a long run, actually 3, I think, there's 3. At least 2 or maybe 3 days to the extreme warm event tally since the beginning of this time series. And extreme warm events are days where the aerial extent is at least 2 standard deviations smaller than that calendar day average. So we have 1 here, there's 1 here, and I think there's 1 there. That makes the score, I think, 198 to nothing since February 1994. There haven't been any extreme cold days by the same definition, 2 standard deviations above the calendar average since that time. Not 1. This right here, the first day where we poked right around Christmas time, we poked a little bit above the 1 standard deviation departure from average, is the first time that's happened at all in December, January, February since 2012. So it's been 7 years since we saw even that, and that's a little bit of a thing. So lots of really interesting stuff going on for this year. This time series, when you add up the positive and negative departures from average, ends up being the 15th warmest, so smallest area on average in the last 71 years. And 12 of those 15 warmest have occurred since the turn of the century. So there's no global warming hiatus. That's all such, yes, it's unbelievable. There's no such thing as that. And we did have two major buildup events in the month of December. One from the beginning of the month to about the 8th, and another one from about the 15th to the 25th or 26th. And that was it. After that, you can see the year was pretty much status quo until the end, when we had a fairly sizable reduction. And this coincides with all the extraordinary warmth in the British Isles and Western Europe, among other places. But that's one of the big effects of that. And the last thing I'll say is our extreme cold wave here in the central U.S. and very limited regional extent of that was right here, right about the beginning of February. And the hemisphere was well below average at the time. So, of course, the weather in your backyard has nothing to do with what's going on larger scales. But intriguingly, I'd like to know, I've never looked through the long time series to see if there's anything characteristic about these real big buildups. This is well faster than the climatological average. And I wonder if there isn't something kind of curious about those features, circulation-wise.
Isn't that coincident with the sun starts to warm?
The second one, the end of it, I think, is coincident. Wasn't it end of December we had the warming?
Yeah, that's what I'm thinking. I'm thinking that whole excursion upward might be the release of the cold air off the polar regions.
So this big buildup going from the 15th to the 28th,
yeah,
is but doesn't the warming event coincide with the end of this?
Yeah, well, I mean, the warming event's when it's gone. But, I mean, leading up to it, the cold air is draining off the poles and probably raising or cooling the 850 millibar over your area.
Oh, I thought.
You see what I mean? It's normally up at the pole.
Yeah, I thought, okay, I had it wrong in my head. I thought that the spill out occurs when you break the polar vortex down, not that it builds up. It's spilling out.
Breaking down,
raising down,
spilling. I think they're coincident.
All right. Okay.
So I think what I'm thinking is it's breaking down during that trajectory up.
Yeah. Okay. It might be true. I think it would be worth taking a look at, what's going on at 50 or 10 millibars in this same, sort of 10-day period. That'd be really interesting. And then to go back to 71 years, I got a picture like this for every one of the winters, all the way back to 48, 49. And one could probably find similarly abrupt increases in the aerial extent and see if they are tied to something circulation-wise.
Yeah.
Like that. It'd be kind of a fun thing to do.
Yeah.
So this is the only thing that is of interest for this whole time series is these two, but especially this one, because I think there is a relationship to the warming event. And then the year just flattened right out. It just never recovered. That might be reflected in whatever happens afterwards. So anyway, that's the a way of looking at the complexion of this past winter. But it's hemispheric, which is often at odds with our parochial view. And that's kind of the whole reason I ended up doing this analysis. I wanted to break that mold that I know I'm guilty of, having too parochial a view of the winter. So I've enjoyed doing this, but I'm not sure where it goes next, except for things like this, looking at extreme buildups and what do they look like from other perspectives. Okay, so let's go now to take a look at the more approximate satellite movie over the continental United States, and we'll look at the West Coast one as well. There's a nice little disturbance right off the Oregon coast that you can see. It's kind of pretty to look at. But here's what we have in terms of our fake color or whatever it is. I don't know what it's called, but it looks pretty nice. And you can see, sometimes you don't see as much of the detail with this as you can see in the infrared because you can't tell the cloud differences in height. This looks like snow coming down across us or to the south, but I can't be sure that's right. Maybe it is going to look like it's moving. But Pete, I'm so unfamiliar with this, I can't look at it. Can we look at the infrared? Yeah. Thanks. Okay, great. Not unfamiliar. Okay, so here's the infrared picture, and this is disturbance number 1 on the East Coast that Michael's going to tell us a little bit about, I think, in the forecast. Taking shape in the cloud, and we'll see later on in the radar reflectivity field as well, rather rapidly. It had some organization early this morning, but I bet it looks better now than it did when I presented some of this to class at 11 o'clock, because it looks better on the satellite picture. And then a lot of cold air back here in central and western Canada. We'll see that reflected in our upper level shots. It's as cold as about -30 north of Lake Winnipeg, and that's not too far away from us. So the exact trajectory of the center of that cold air is going to really determine how close we get to getting to the second coldest day in March ever. And we may make a pretty good run at it. And then there's yet another plume coming out of the eastern Pacific and smashing into the southern or central part of the California coast. They've had flooding problems already in LA and places to the south of LA and then all the way up to San Francisco. I think the snow level has gone up because it's warm, and that's bad news because some of the prior snowfall might melt a little bit more earlier than anybody there really wants. You can barely see on this image this little disturbance right off the Oregon coast. Absolutely beautiful little cyclone. So we'll take a look at that in some more detail in just a minute. So we're going to watch what happens to the storm on the East Coast in the forecast. We're going to watch what happens to the cold air that's quite centrally located in one spot here and just north of the border to our north and west. And we'll see a little bit more of what's going on with that disturbance in just a minute. Let's look at the radar first, though. Yeah, so the line of heavy weather along the southern bit of this, as I say, organizing weather system here in the Carolinas and the southeast states is pretty intense. So some reflectivities in the 50 or greater dBz range across southern Georgia and the northern part of the panhandle of Florida. And earlier this morning, maybe you could see it, just a little spot where it gets purple. I think it gets into the 60 dB range right down in far southern Georgia. So maybe some big hailstones with water on it or something falling on that. And here's a semi-organized region of light snow, and we'll take a look at the surface off in just a minute to get a sense of how intense that might be. This will have some impact on us overnight, but probably later tonight, and not a very big impact. All of the card winning at Melissa's house will already be done, and the trophy will have been bestowed upon me by the time we see a Flores. I'm guessing that will be the case. And if we can slide over to the west coast, even though we'll see this interesting disturbance off the Oregon coast, with cloudiness and so on, there isn't much precipitation falling out of it. And that's not a function of no radar installations. There's one near Portland and there's one in the northern part of California. So that would do a pretty good job of resolving what's going on along the Oregon coast. It's just not rain, it's just cloudy and probably windy. And then here comes some of the next round of precipitation from that excursion from the south that's going to hit just south of San Francisco Bay, it looks like.
Has Seattle been pretty dry this year?
Not in February. They had the snowiest February they've ever had.
Well, snowy.
Yeah.
But I wonder about actual precipitation.
I don't know. Yeah, I guess I don't know that. It's not a dry month for them. It's usually a dry month for us, and we finished maybe in the top 2 or 3 in terms of total precipitation. We were well above normal.
Right, but so many of these systems are coming into California.
Yeah.
Up there. I'm wondering if most of the water is being brought in California.
I don't know. That would be what I would integrate over all these Fridays, though. Yeah, I would think the same thing. I don't know. Okay, can we take a look at a close-up on the West Coast, Pete?
Close-up radar?
No, satellite.
Yes.
One that I like. Yeah, that was
Or you
probably...
want
No, I think this one was really good. It gave us a nice picture of that thing off the Oregon coast. Yeah, so this is the one I saw earlier today. And it's slightly different time. But look at that beautiful circulation. Pretty small scale. I mean, these are not small states, but they're not giant states. And this entire circulation pretty much would fit in Oregon or Washington, one or the other. And there's the clouds along the coast. But as we just saw on the radar, it doesn't seem to be precipitating much. And the clouds themselves are getting warmer at the top, and the cold cloud drops are dissipating a little bit. But there's a lot of circulation in this thing. And it's not just one center. I think you'll see it. There's a little bit of a secondary circulation in there and so on. If we can look at a water vapor image at the same thing, you can see some of the roll up that goes on around the edge of that. We noticed that this morning. Unfortunately, this thing gets a little bit in the way, but you can see these little vortices that roll up. And this is the low level water vapor, right?
That's mid-level. You want low level?
No, this is better than the other. But you can see a couple of them there. They're nicely spaced. There's one. Here comes 2, 3. So it's like a string of pearls along that shear line on the inner part of that little vortex. So pretty nice. Too bad we get a little bit of that fuzz.
I think we've gone through the worst of that. I think that's getting better now. So.
Okay, so let's take a look at our surface analysis across the country. Or surface off. It's not really an analysis. And let's start at our own location. So we've got reasonably warm day for what we've had recently, 24 and 8 degree dew point, so the air is dry. It's not so dry further to the west, in terms of the dew point depression. It's heavy snow in places to the southwest of Minneapolis, moderate snow in Minneapolis, heavy snow to the north. So this is that patch we saw on the radar that looked a little bit less impressive than it actually appears to be in terms of the real reports of precipitation. So some moderate to heavy snow in certain parts of Minnesota, then lighter snow in South Dakota. That thing is on its way slowly across the state, and we'll see some reflection of its presence by the time the mid-evening or late evening is here. And light snow in Columbia, Missouri seems rather isolated. So, but there it is.
So with it sort of dry over us, I guess that's also going to play a role in how much we eventually get, what our temperature trend's going to be as that precipitation arrives overhead.
Yeah. These dew points in our vicinity are not in a different category than the dew points where the column is close to saturated. So I think what we'll see is the temperature will come down, and we may be able to sustain almost the same kinds of snow intensities as reported here, but perhaps not. We'll see. Let's see, where else did we want to go? Just a survey, I guess. Moderate temperatures in the Atlantic coast, in New England. It's around freezing just about everywhere from central Maine all the way down to New Jersey and Philadelphia, home of Bryce Harper. Good luck to the Phillies. What a mistake. That's a cancer in the clubhouse waiting to happen. Are you kidding me? He should have been signed by San Diego. Then he and Manny could have fought each other all year long. That would have been even better. So Phillies and Padres are history. So here's a kind of a broad moderate temperatures for early March. The precipitation and the organization that we saw going on in the southeastern United States is fueled by really high dew points. Dew points are in the 60s, widely across Georgia, South Carolina, and Florida. And moderate, sometimes light to moderate rain across the Carolinas and the Appalachians in western North Carolina and Tennessee. And we had, let's see, the other place that looked interesting weather-wise was along the west coast, on the coast of Oregon. Moderate rain in southern Oregon, like Coos Bay, I forget what the station is. So moderate rain there, and that's tied with our cyclone offshore. And then you can see there's nothing yet falling, at least in this limited number of observations, in the central part of the California coast, but that's not long. You don't have to wait long before it can stop to rain there. And it's warm everywhere. Look at the valleys in the mid to high 50s. And the dew points are really high, so I think the snow level is really high. Okay, let's take a look at some of our upper level charts. Let's start with the super peat at 500, maybe. So here's 500 millibars this morning at 7 a.m. It's kind of a weird pattern. When we were looking on Wednesday, Michael, when you were showing us all that stuff that you can do with the thread data, and we saw the stream function, I thought, man, that just looks like the weirdest stream function field I've ever seen across continental North America, and the geopotential height looks equally weird. But here's what's embedded in it, minus 46 at 500 millibars over central Saskatchewan. Okay, so that's really cold air, and it's, again, limited in its aerial extent, rather like what we saw at the end of January, this really kind of really small scale, intense upper vortex with cold air as a sort of skirt underneath it. And then here's the disturbance right off the Oregon coast that we're seeing so nicely in the satellite picture, and there's a broader trough off to the west of the California coast, and the southerly flow induced by that is dragging that tropical plume towards San Francisco.
Another big split flow.
Yeah, definitely right. That is definitely right. And look at how one branch of the flow goes all the way well into the north of the north slope of Alaska, then comes back to the south, leaves this all in the lurch, and then little waves are bound to come out of this northerly and northwesterly flow. This might even be one of them. And there's not much to prevent a southern swing of this exceptionally cold air, and that's why we're under the gun, it turns out. Here's a little trough. This might be the thing that's kind of putting some organization to this precipitation over the eastern United States. That's a little bit of a synoptic scale trough. It's got not only curvature, but some shear, because the speed is stronger to the south. So pretty decent region for development in this location, and that's roughly where we're seeing things kind of put themselves together. So
I was going to point out another curiosity.
Yeah.
Today, March 1st, is the Springtime Tallahassee Festival, and they claim to be the first place in North America to experience spring.
Oh, is that right?
Yeah, because they get a real winter in Tallahassee.
Tallahassee, yeah, right here.
Yeah. So today's the celebration.
Oh, I didn't know that. So that's they're maybe a little premature. It's going to be chilly.
They could be.
Yeah. So some of the stuff they're going to be celebrating will be subverted for a few days, but not for too long.
No, it's nothing. Yeah, just another comment about this pattern over the central and eastern Pacific. The split flow about everything that's going around northern parts of just the north slope of Alaska and then back southward over the central or the west coast. There's also that southern branch around the trough that's just south of the ridge.
Yeah, right. Yeah.
So these weather systems have come in from the far western part of the map, and they can split apart, go around, and this whole issue that used to be a big problem, it seemed, back in the 80s and 90s of the phasing of these weather systems that came back together.
Yeah.
Potentially came back together. The timing of it and the interaction of it can lead to big forecast issues across much of the continental United States. I'm wondering if this pattern perhaps has contributed to some of the forecast uncertainty we'll talk about when we get to the forecast.
Oh, maybe, yeah.
Over the central and eastern United States. If you recall, a week ago, the models were forecasting a fairly significant snow event for us.
Yeah.
This Friday into Friday night and Saturday. It's gone. Right. The only semblance of it is that wave that's over central Montana. Right now.
Yeah.
You sort of see the short wave there that is
right.
Modest bit of courage.
And that seems a little too far west to really be the organizing factor for the snow in Minnesota right now, but maybe that's the only thing we can think of, at least in Upper Lakes.
Right.
Yeah, you're right. That's a good point, because we did have looming for a long time, a February 27th, 28th snow event, and it looked like a big one. It completely disappeared.
Unfortunately.
Yeah, unfortunately, the cold air is still there. Right. So let's see what this looks like at 700 millibars next, if we could, Pete. So first we'll go to the cold air. This is the minus 30 isotherm, and it's as cold as minus 35 in the analysis. There's a station near, like north of Calgary, I guess, and it's minus 35. So that's darn cold for 750, 700 millibars at the beginning of March, and a really intense low-level baroclinic. So I am mid-level, I suppose, at 700, with flow that's more or less parallel to the isotherms on the warm side. It's slight cold advection on the cold side. So this is an intensifying baroclinic zone. At 700 millibars. One might expect it to induce a transverse circulation with ascent on the warm side. And that's occurring generally in a region that's downstream of an upper trough axis. So this is probably why things are getting organized over Minnesota and will move into Wisconsin during the night. Look at this, minus 10 at 700 millibars, but way up to the north slope. That's really warm for them, really warm. And yet, isolated cold area right over the central western provinces of Canada. So again, it has a characteristic that looks a lot like that cold snap in January. Very small scale distribution of the cold air underneath an upper vortex of some intensity. In fact, can we go to 300 and see what it looks like there? I should have done that first. So here's the vortex at 300 millibars. It's part of an oblong peanut-shaped vortex, and this is the western periphery of it, western edge of it, minus 47. So it's almost isothermal from 500 millibars to 300, which means you're probably, the stratosphere is really low. It might be almost as low as 500 millibars. Maybe we'll take a look at the sound just to see what that looks like at some point. And then we've got here's the trough at 300 millibars, a little bit further downstream, it looks like, than it was at 500, and with a stronger wind speed feature upstream than downstream, that tends to dig these things a little bit further south and make them a little more intense. Okay, and then if we could go to 850 before we take a look at the sound.
One last thought on that. I mean, this is this pattern and the temperature anomalies associated with it, especially over Alaska and maybe into the Arctic, always has me wondering. Like, I don't know the climatology of when sea ice starts to like melt up there, or things like that at the right time can affect that. But
yeah, they tend to measure the seasonal maximum extent somewhere in the middle to end of February. So this is the beginning of the recession of the ice. But maybe it's exacerbated in cases like this. And where is it exactly distributed is always going to be somewhat inter-annually variable. I don't know if there's an excess or a deficit of ice in the North Slope region this year. It's a good question. Really good question. So let's see what it looks like at 850. So at 850, you still can see this isolated spot where the air is exceptionally cold, minus 31. Just to the north of Calgary, and that's roughly where you've got a deep column of really cold air. And so one imagines this small scale set of isotropes underneath the positive PV anomaly at 500 millibars, and then there's just a skirt of cold air that's contained by that structure. Sorry.
That's near the surface around.
Yeah, that's right, especially to the west.
So that's got a lot of sinking to do to get here.
Yeah. It's pretty cold to begin with. Yeah, the one we got in January came straight south like this, not on the
Sure,
side.
it was much further to the east than
Yeah.
than this one.
But can we look at a sounding though, Pete? Let's take this sounding right here. And I don't have enough experience looking at, I don't have enough experience looking at Arctic soundings because they do look different than mid-latitude ones, but here's what we have going on. So at about 700 millibars, that's where you have this kind of isothermal layer and it stays isothermal all the way up. I don't know what that means about what we're seeing there or not. Does anybody else have more insight about that?
Could that be the purple one?
Yeah, that's what I'm wondering. Is it that low? It's possible because it's cold all the way to that, through that spot.
Looks like it, doesn't
And it's at 700 millibars. So we've got a really low tropopause, a pretty intense TPV, and it's got a small skirt of cold air. And so in the forecast, we're going to watch what happens to that, the boundaries of that skirt. Where do they go? And if they come over us, we get exceptionally cold. If we get close to them, but not directly hit by them, not quite as cold.
It's unusual for us to get exceptionally cold with one of those systems so far west.
Yeah, it didn't happen in
It
January.
always comes from straight.
Right, it didn't happen in January like that. That's right.
So that's actually it'd be an interesting project for undergrad to look at the colder outbreaks, define it by some measure, and then look at the trajectories of the air forces.
Yeah, right. It would be really interesting. You learn a lot about these things by doing that. And I think also we might see in the forecast, this event, even though it starts out with this kind of small scale structure similar to what we saw in late January, I think it floods the eastern United States with cold air. So it is something different at the far end. Yeah,
All the way to the
it's different. And so Tallahassee's going to have this nice celebration on today and tomorrow, but it's going to get cold on Sunday and Monday, which is weird. It's not what happened with January 27th through 30th.
So I think the nature of the vortex, that was, I think, even smaller and just much more intense.
It's very much cut off.
water type of circulation.
I think you're right. Even in the 500 millibar vorticity, it doesn't look that impressive. In fact, let's do that one last thing. Let's look at the 500 millibar vorticity from the analysis. Got 500. I'm sorry. Yeah. Yeah, so this is not, it'd be nicer to look like that, but it looks kind of, this is the vortex structure, and it's connected to a shear line, and it's just not the same animal. Just not the same animal. It's got elements that look similar, but it's not the same thing.
Okay, that does not look like a cold air.
No, it does not. It does not, but
But actually, this will be a more impactful one, as John was saying, I think, for the central eastern US than was the one we had back in January.
Yeah, that one was very regionally constrained. This one, in the end, does not end up that way. Well, that's all I have.
Okay.
So.
Right, so a couple things to talk about. This is a relatively quiet weekend. We're going to get a little bit of light snow. I haven't done it in a long time. We'll go to the Aurora and all that stuff is the DBU site. Yeah, the most recent max stuff should be no, let's go back quick, too quick. With the 12-0. Now, first, let's go at the bottom. Don't go to the bottom for the time weight. Haven't done this, so the VURograms first, though. VURogram. John's favorite.
Oh, yeah, the medium. Yeah.
VURogram. So this is the forecast for, those initialized at 0Z last night, through 60 hours, so ending 12Z on Sunday morning. And what it shows is, let's say our daytime highs being, again, relatively mild today. I'm expecting to get into the middle to upper 20s today. But the key thing is the onset of our snow just right after 0Z this evening, so after 6 p.m., a period of light snow ending by really early tomorrow morning, so you can see the accumulated precipitation. And then a hint of maybe some more late on Sunday. Sorry.
But you're not getting much lower than the teens at night.
Right, so this is
Until
very,
Sunday.
I don't really trust that.
It only goes out to
Sunday morning, right. But maybe I hinted something else Sunday morning. But the big thing is this precipitation, this precipitation. So if we now go to the time height section, we can get a sense of what's going on. And what that is again, just to reorient ourselves, we have the yellow contours here represent the isotropes, the potential temperature contours. Red is relative humidity above 70% contour. Minus omega is the solid lines here, so this is the upward vertical motion, ascent, and the descents of the dashed lines. And you can see in the forecast, and then also the green line right here, is our dynamical tropopause. So you can see this modest short wave that goes by overnight that gives us a little bit of precipitation. You can see the mid-troposphere, this is really a mid-troposphere driven disturbance that doesn't really have much impact or obvious impact in the lower troposphere. You can see these isotropes in the mid-troposphere blowing upward underneath this cold dome and then slowly receding once its upper trough goes by. That's kind of interesting. That's, I guess, the strong stability in the lower troposphere is kind of decoupling the circulation, so it's kind of riding along a surface that's somewhere around 700 millibars or so. Somehow this PV anomaly is not able to pull up all the way down to the lower troposphere, this dome of cold air, so that also indicates the strength of it. But as it approaches, we get this strong ascent that's occurring. The column air parcels are cooling and trying to reach saturation. And so we're actually getting this upward vertical motion that leads to the precipitation that we see at the surface. I believe if we looked at this on a more northern route, it would start a little bit earlier, maybe in Minneapolis, but you would see maybe more vigorous vertical motion and higher accumulations of precipitation. This goes by, and then we got a change here. Doesn't think it's warming up much, or there's any obvious tropopause depression going by, but the column then moistens up once more with other bursts of vertical motion, which is not, now this might be warm advection that's occurring, that's leading to this vertical motion and this light precipitation on early Sunday morning. Let's now take a look at the forecast maps for this. We'll look at also the pivotal maps in a bit. In the forecast, let's start out at our current time at 18 hours before. So this seems to have captured pretty well the light precipitation that was occurring in the Dakotas and in Minnesota. This is accumulated precipitation through 18Z today. Really intense cold air that shows up at this minimum over Alberta or Saskatchewan, Alberta and Saskatchewan this morning. The heavy precipitation that we saw in the southeast United States moving into the mid-Atlantic is a little bit ahead of schedule, perhaps, in terms of what's actually falling and being reported at the ground in Delaware, Maryland, and Virginia. And some of the precipitations on the west coast gets captured as well, in terms of at least accumulated precipitation. If we go ahead 12 hours to midnight tonight, we're in the light precipitation. At this point, it's very light precipitation. This is continue to move along. Not particularly, in my mind, very exciting. And the biggest weather stories are going to be on the coast of the United States, the west coast, but then beginning to just arrive in California, eastern California, the Bay Area, beginning to get some rainfall. And this cyclone beginning to develop along the southeast United States into the mid-Atlantic.
There's again totally missing Seattle.
Yeah, so this is just high and dry. That might be a very close sense. Yeah, for Seattle. And we'll go ahead another 12 hours. And this cyclone that develops on the East Coast, we'll keep going forward. It was something that actually wasn't captured in the forecast just 24 to 36 hours ago. We're going to look at that a little bit and how the forecast has changed. So this, at least in this model, is a pretty robust cyclone at just 1,004 hectopascal, intensifying with a precipitation shield just grazing southern New England in this particular forecast. We'll see the GFS is a little bit more impressive for eastern New England.
I think this minimum up there is slipping at almost 1,000 kilometers to our north.
Yeah, that's right.
That's a really quick transit of that eastward. That's a little curious. But our precip is over by tomorrow. By tomorrow morning, it's over. So in the afternoon, perhaps cloudy, but we have weak cold advection occurring with this trough that hangs back from the cyclone off the east coast, and this ridge that's beginning to build in to our west. So cold advection has started, but it's not particularly strong at this point. And again, the western United States, particularly central California to the south, gets another burst of rainfall. All right, let's go ahead to 60 hours, well, 54 hours, just to 2.12. And this cyclone begins to intensify in the North Atlantic, south of Nova Scotia. And this weather system that was just off the west coast at the beginning of our forecast period is now raced eastward, redeveloped in the lee of the Rockies. You can see a nice thermal ridge here and accompanying hydrostatic reflection that the trough that's moved into the Central Plains. And this is going to be a big weather maker in terms of upslope snow to the north of it, north of this particular cyclone. And having looked at this carefully, maybe Greg might have some comments. We'll look at some other maps. We're going to see as this moves into the the central U.S. and southeastern United States, will there be some severe weather perhaps associated with this particular cyclone. Okay.
Looks like it's set up. Yeah, it doesn't look like there's a lot of moisture though in the southeast at this point.
Right. Yeah, that's interesting that broad ridge that we had seen in the last several weeks has kind of receded, at least temporarily, to us.
Yeah, it doesn't look conditionally unstable just from that picture.
We can't just look at it. Okay, we can look at some soundings once we get to the pivotal stuff. And this was a really, from my perspective, rather quiet weekend. One other thing to note, and we'll compare forecasts, is at least in the MM5 forecast, and the 12Z run will be out a little later. We have to scheduling of these jobs and so on. Is the latitude of accumulated precipitation. If you go to the 60-hour forecast in the MM5, we're just on the southern edge of this developing snowstorm. Now, I don't believe the 0Z GFS or any of the 12Z model runs this morning have a precip this far to the north. So it's just something to watch. There's some uncertainty in this. And the expectation right now is that this weather system is going to pass well to our south by probably at least 100, 200 miles further south than they have a precip here.
We're in the northern edge.
We're the northern edge of it. Sorry, yeah, northern edge of it. This should really be much further to the south. Well, I should say should be. The expectation is that this is going to be much further to the south. So let's, before we get there, I want to look at the potential vorticity. We can step forward. We can just animate this actually. So let's step forward and get. So we're looking at that short wave. This is too fast. I'll go to 18Z. Sorry, Pete. Stop that. Let's start at the 12Z. Then here's the upper trough that we saw at 12Z that was located a little bit further to the west. Shows it really nicely right here. So this might be that feature, even though it was kind of west, a little bit further to the west of the surface map. We can go back to the 12Z and see how it's progressing. It's moving along pretty well.
Yeah,
It's pretty rapid. Actually, but we know that this feature, since it's a conserved variable, as long as there's not significant diabatic heating or friction at this level, this is going to be proceeding. This will proceed to the east, and you can just track it, its motion eastward. So if we go to from 18 hours to 30 hours, from midnight to night, that trough is pretty much right on top of us as it goes by. It's a little bit more intense further to the north, so we might expect, in terms of accumulated precipitation, greater precipitation just downstream of the trough with more robust upward, more robust ascent. Let's go ahead to 42 hours. And this feature is long gone.
That's what you had in your media wearing with the lower tropopause height.
Yeah. Right, so it's already gone by, right? So that's already passed by. I will now ask Pete just to go back to the east coast of that. I want to focus on a couple of things. Look at the animation. We'll animate this and just watch. Again, the lighter these colors are, the lower the potential vorticity is. And one of the things that you'll see that's really interesting is as this east coast event begins to develop, and there's actually some interaction even with this upper trough as it goes by. Notice the lowering of the potential vorticity downstream of the wave. I wish we could stop this, but in the last few frames, you see this lowered PV downstream of the wave. That's a reflection of the PVs being lowered and it's not simply being affected. That indicates there's diabatic heating that's going on at the level below this. And so that's eroding the potential vorticity, but sharpening the upper trough. So the intensity of the upper trough, I think, is playing a role in what helps focus this cyclone that wasn't forecast in the model a few days ago for the East Coast, making it a little bit more intense. If we can stop this peak, go to the pivotal site. And I'd like to look at the two things. You had suggested this before. We're going to look at the same set of maps. We'll go into the dynamics maps. And let's look at the data on what? This just shows the potential temperature along the dynamic and tropopause. And one of the things to point out, as John was noting, this elongated vortex that existed with this next, what we're associating this with the next cold air outbreak, it has a skirt of much lower temperatures beneath it. This is really stretched out. It's not that isolated ball that we saw before. It's not a very strong vortex, not even like the one that's off the west coast of the United States. And so I'm wondering if, because it's not this really strong circular vortex with really strong winds around it, if the inertial stability around it is one such that it's not going to help contain that cold air and keep it right directly beneath, and keep the skirts, the isotropic skirt, if you will, that's associated with it, doesn't keep it rigid along the edges. It's going to sort of fan out a little bit as this begins to move south. This isn't a very strong vortex. It's just a really large area of depressed tropopause. But I guess, Pete, you're suggesting we want to look at the location of the dynamical tropopause at that sounding location. It gets down to about the 640 or 670. Yeah, close to 700. So we're probably looking at the sounding data at a pretty good representation of the tropopause. Okay.
The other thing about it being linear is that it produces a wind speed maximum to its south.
Right.
And that has transverse circulations where it's circular. You don't get that. And so this may be an easier way to keep things contained. Another way of thinking about
that's a great way.
Geometry is very important.
So with these anomalies also, it's more characterized by stability or by vorticity or winds, which is what John's just pointed out.
It looks like during this event, the tropical tropopause is staying well south. It's subtropical jet mostly east-west and not blooming up at all, except much further out in the Pacific.
And there's a little bit of blowing up out over here. So what I'd like to do is go to the surface and precipitation maps, go to the precipitation rate. Let's go to when this cyclone off the East Coast is really well developed. I forget the time. Go to 60 hours. Make sure that's not too far out. Not the one that I want to focus on. Go back, please, to 36 hours. Sorry, I'm getting my times. All right, so 36 hours, we have this, and if you can go back a few more clicks. I think I went way too far ahead in this. Okay, so this is a 30-hour forecast for tomorrow morning with the cyclone that's southeast of Cape Cod and Nantucket at 1,000 hectopascals. If you were a forecaster looking at weather data, or back to, I think it's Tuesday at 18Z, this is what you would be. This is a map out at the same time. So on Tuesday, you were forecasting for southeastern New England for the weekend for Saturday noon, for Saturday 1 o'clock in the afternoon. It's probably a pretty nice day. Maybe some clouds. It's, there's a flow off the water, but it's not going to be that bad a day. Wouldn't have any precipitation hazards. No impacts to visibility perhaps expected at this time. If you were to then go to let's say Wednesday at 12Z. The Wednesday morning data, I think you'd reach the same conclusion. This is not a big deal. There's nothing going on. You'll notice that there's a trough that's kind of beginning to creep up a little bit toward the northwest from the cyclone that's way out in the Atlantic, but okay, no big deal. There's not much in the way of precipitation with it. Let's go back to later. Now the models are finally, instead of having a trough, they actually have a closed-off cyclone that's located east of New England. There's an easterly flow, perhaps just around Cape Cod, but again, not a bad day, but it might be for mariners, maybe stiff east wind out, when you get south of Nantucket. Let's go to, this is what,
just
12 yesterday. Okay, so yesterday, finally, you're beginning to see that there is the possibility of a fairly significant precipitation event all the way into, even west of Worcester. They're expecting to get some snowfall with this in an east wind.
Bald spot at Albany, though.
Right. So it's probably that. What's that feature in Albany? They call it the
Mohawk River Valley.
Yeah, valley.
Drainage.
Yeah. Drainage. So that's not going to get it. So sorry, guys.
Yeah.
Steve Ross is watching. Let's go back then to last night. You can see this is getting really nice. If this were verified, it hasn't verified yet, but significant precipitation in this. So this is really interesting. You have this situation. You went from basically nothing to now the 12Z forecast. Valid again. All maps are all valid at the same time. A fairly decent cyclone that's going to produce. They probably haven't looked yet, but they probably have winter storm warnings perhaps for an event of this sort. And it wasn't in the forecast on Tuesday. It wasn't in the forecast on Wednesday. Thursday, beginning to see evidence. So one of the things I was kind of curious about was what was if you also look at the fitness field, you can see there is a little bit of a fitness minimum here. You could argue that part of that's due to the fact that it's a more intense cyclone here that's helping to keeping the trough just upstream of it. But let's look to see how the upper troposphere has changed. And so I was looking at the dynamical tropopause maps for this particular event, going back to this. Let's look at some of the differences. This is Swiss theta. I think that'll be a better representation. So where's the upper trough associated with this event? I'd say it's this little pink area right here. It looks fairly modest, but if you look carefully, look at the structure of this now. Look downstream of there's some blues here and some grays. It's pretty well carved out. It's pretty evident that there's an upper trough on the dynamical tropopause in this map. If we go back to all the way to the first forecast time, 18Z on Tuesday, there's nothing here. It's fairly broad. It's kind of amorphous. There's no, in both the winds or even in the theta along the dynamical tropopause, there's not much evidence of a robust upper trough. There is something down here. That's where we saw the inverted trough. If we go back, I don't want to go through every single map time. Let's go to Thursday 0 to Z. We need to get something that's a little bit different. It's much further to the east, but there is certainly a little bit of a trough feature here. And if you look at the surface map at this time, we'll probably even see a little bit of precipitation downstream of this, or cumulative precipitation. Right, there's a little cyclone right there that's associated with it. Let's go back to that map and go to yesterday at 12Z. Again, you can see this trough getting better defined. And so I'm wondering, one idea might be that the latent heating that's occurring with that was in the vicinity of that inverted trough. It's a chicken or egg thing. You have an upper trough here that's going to be vertical motion downstream of it. But part of that could be basically with the self-development type of effect, with the latent heat release helping to build a ridge downstream of the trough and sharpen it up. Let's go back to the final time.
I've been looking at the inertial stability, and you seem to be completely correct on that.
That's what's happening.
That it's dropping right there. It's getting very small.
I think it's nice
It
consistency.
must be, and it's kind of an isolated bubble, so it looks like it's coming from that.
From latent heating. Okay, so if we could actually go back in time, let's go to 24 hours, keep this map up. You can sort of see this upper trough. It's fairly, okay, I mean, I won't write home about upper troughs to my parents, but it's not something I would write home about this. This looks pretty innocuous, at least in the color scheme that's here. Go back a little bit earlier. You can see these lodis of, you want an earlier run or no, earlier time is really fine. A little bit earlier. Again, just a thin upper trough, this feature is pretty narrow in here. And this was something that if we were to go back to the same time, how early can we go back? But go back to yesterday, maybe 18Z, 12Z yesterday probably still would be in the forecast, right? So that's when it was beginning to show up. We still have this little feature here. So what would be interesting is to track this back in time and see its origin. Okay, so let's go back to the surface precipitation map.
Yeah, this thing would never develop under those circumstances over the continent. No chance. Because there's no diabatic heating. At least not in August.
Yeah, at least not yet, or at least the timing and the location of the upper trough. So let's go to 48 hours of the forecast. And I just want to compare, I'm now jumping back, to our weather situation coming for this weekend. Snow's long gone. Here's this weather system emerging into the central plains. Look at cold advections over us, pretty stiff winds out of the north. And we also have the precipitation. Remember the MN5 had the precip shield all the way up into southern Wisconsin. Here it's all the way down in southern, not even reaching southern Iowa at this point. It's at 1054 high coming in. Yeah, that's a pretty powerful high. And we go to, 60 hours in the forecast. This heads east, so the East Coast is, under the gun, so to speak, for another snowfall event. In this case, down in the DC area, getting snow, but we're really in the cold advection. But one of the issues for Monday morning for the chancellor to deal with is they have those minus 35-degree wind chill criteria if they're going to close the university or delay the opening. Let's look at least the forecast wind chill for this event. And we can actually zoom in a little bit. Do that, get a regional. But you can see it's not going to be quite at the minus 30. So So we will be open. Sorry, folks, if you wanted to get a delayed start. But this has also changed over the course of the week. If you go back to Tuesday, and we had temperatures that were minus 37, minus 35 for a long period of time, and this has warmed up. So it's probably,
What's the actual temperature?
the air temperature is like minus 11, I guess, in the forecast. Let's go to the current forecast. Minus 19.
That would have been nice if we'd have broken the record, almost, in second place.
Yeah, wind chill, yeah,
We still
minus
might.
13.
We still might.
Getting
Minus
close.
14. Yep.
Yeah, minus 14 is the record.
second coldest.
You know, this is coming off of, damp up in there.
Right.
How are we gonna get this cold? That air coming from over there, right? In the center of the thickness minimum is way, way
To the
north.
north, right. Yeah, so there's a couple differences you're pointing out. One, the thickness minimum isn't directly over us, like it passed pretty much right over us, or actually
Yeah.
slightly to our south when we have a cold air operating. Let's go back to that bigger picture. I know we have to run.
It's like a great purple spot.
Yeah, so, precipitating rate. Thickness minimum, way over here. In fact, the minimum is that little spot right there. So we're just in cold advection, not nearly as cold thickness-wise as we were in the prior event. And if we just step forward, also notice how this cold air is just going all the way down. Anticyclone is just riding the east slopes of the Rocky Mountains, all the way down to the Gulf. Look at that. I think they have a little bit. I think we were getting below 500. We can just go back to Tuesday. Just use that as the furthest back, to keep the temperature, the time the same, which is the longer one. That's actually faster. Let's go back to 144 hours. Make sure we compare apples to apples. Go to 12Z, please, 138. And so compare this 12Z Monday morning with the current forecast. A huge change.
It's not a huge difference.
Right.
It's a little difference, a little bit warmer.
And if you go back to Tuesday again for just one other thing, it's this event that's off the East Coast, even there. No, some elements of it perhaps, but that's not.
It's not something you can argue with because it's windy and it's mixed, so it's gotta be a pretty accurate forecast. It just seems odd to me that we're getting that cold.
Yeah. So back to the forecast, and we'll just quickly step ahead. A couple of things that are coming up next week. We'll see if they even manage to verify. It's got 162 hours, so just before Weather Watch next week.
Yeah.
There you go, John. Last the night of the season, maybe. Hopefully.
No,
Probably not.
Really.
But yeah, we're gonna have a nice cyclone passing just to our south with this model forecast. This forecast verifies with some snow over us.
It's a perfect track for like 5 inches of snow, maybe more.
Right. Remember last week we were talking about a perfect track in the for this time right now, right? That cyclone was supposed to go.
Yeah, that's true. I can either confirm or deny that I participated in that.
Let's go to 240 hours. This is just 10 days out. I'm just trying to-
Mhm.
that would bleed. Let's go back to 222.
Look at that.
Yeah, you got another cyclone, but it's probably going to be heavy, at least at this stage. You don't want to look at specifics, it's going to be
Very
north south. Then finally, let's go to, just before we leave for spring break, look at that. This is in spring break, right? Let's go to spring break, for, and we're going to, the last weather watch before spring break, just before that, 12 hours before that. Look at that.
That's next.
Yeah. Thank you, John.
That's nice.
And then let's look at the, one of the things I've been really focused on with a lot of curiosity is the winter weather, look at the snow on the ground. I know people are tired of this drab looking snow. Either we want a fresh coating, which everyone wants, right? Or we want none. So at spring break, we have none, we have some, just before spring break, we have some. But at the very end of the forecast period, look at this. Poof. Warms up. So the mounds are going to be there, but the undisturbed areas will have melted. Supposedly, if this is accurate, will have the depth of water in the streets. Yeah. A lot of slush. And then finally, the temperatures, when we begin entering spring break.
I hate to rain on your melting parade. I mean,
Yeah.
This is climate. Okay, I mean, that's what happens by the time you get to 17th of March.
But this wasn't always in the forecast. We've had,
That's true.
which is also climate too, right? But we're going to be, could be just, upper 40s, maybe low 50s.
Yeah.
That's going to be kind of nice. Just a couple of
Outdoor tennis.
with coat on it, yeah. Anyway, so it'll be interesting, we'll look at next week's forecast and see actually what evolves with that cyclone passing to our south. But this weekend looks relatively quiet, a little bit of snow this evening into early tomorrow morning, and then just a quiet weekend. It'll be curious to watch how the forecast differences between the MM5 from last night and this GFS from this morning, and how this pans out. But I think most of the forecasts have the snow to our south. I wouldn't mind a big forecast bust that would make weather watch interesting next week, but I don't think anyone here really wants more snow. At least I don't.
I do.
I don't. So, thank you, Pete. Thank you, John, and thank you all for coming. Have a wonderful weekend.
Thank you, Mike. Thank you.
Do you
That's very good.